Yeah, welcome everyone. Today I have a special guest on my channel, Dr. Clark Alexander. And Dr. Clark Alexander is a bright scientist. He is also a unique entrepreneur. He has co-founded several companies, and also he has several expertise and a wide variety of unique publications. And you also patents as well. And Dr. Clark, he sees himself as a data mathematician, which is quite unique name because we, as he said, we have a lot of data scientists, we have data engineers, but why people don't envision having a data mathematician? And the data mathematician is quite unique in that way. So welcome, Clark, to the channel. So that's I'm really happy to have you.
Thank you very much. Thanks for having me.
Yeah, thanks, Clark. And we would like to know more about you in person and how did you start, what you are currently working on, and in all of these momentum, why did you pick Julia to be the center of the universe of your activities?
Yeah, fair enough. I guess I'll start sort of the tail end of the CV. I did my PhD in mathematical physics at Northwestern University, in non-commutative geometry specifically, and I tried to do the tenure track route. So I was there for 10 years, but I graduated in 2008, which was maybe the worst possible year to graduate as a non-commutative geometer, as 2007 had seen a complete hiring spree of non-commutative geometers, and no one wanted postdocs in 2008, and then all the jobs went away. So,
so I thought it is coupled with the financial crisis, but now we see a different problem, right?
Yeah, several couplings, in fact. Yeah, you had to do some decoupling. I did some postdocs, and I taught at a number of universities, and eventually a friend of mine he was a physicist, computer scientist, economist. That's what he had studied. And he said, "Hey, Clark, I need to work on some hard math problems. I'm trying to automate a bunch of stuff in data science that I don't think people are thinking about, and I need some mathematical firepower. You want to come work with me?" And that's it. That's how I became a data scientist. And he originally had labeled me as a mathematical engineer. So that's where I got the idea of like having slightly unique titles, because I'm not doing the traditional data science dashboarding and machine learning model building. So I even started in MATLAB and Octave, right? It was freeware. It's like, oh, Octave, okay, this is just matrices. I can do this. And then eventually everyone was using Python, and I changed to that. And then eventually I wised up and I came to Julia. So since then, I was consulting with a credit company, and I was working on real estate sales, and I have let's see, I traded electricity. I worked for a quantum computing company. I advised a quantum chemistry company. I did quantum information security, IEEE. I work in logistics, and I started a renewable energy company. So,
that's quite a wide spectrum of expertise.
Yeah, I think the thing that I want to say is that there is a through line here, and I realized that people will pay a lot of money to solve hard math problems, and that's kind of where I show up. Right, my skills are not the same as most data scientists. My skills are in like leveraging the harder mathematics on the back end, and then putting that into code. So I give you an example. My very first project I worked on was clustering time series. But what I did is I considered every time series as a quantum harmonic oscillator, and I fitted them to like a third order excitation, and then I was able to cluster them via their Fourier coefficients. And I was like, "What are you doing?" And I don't know. I don't know how to do it the other way, so I had to figure out how to do it this way. My way works super fast.
Yeah, that's indeed. It's like finding a hidden pattern and convert it to kernel, and then you can express or re-express everything. And that's really pretty smart. So I remember those days where people were using Octave as a replacement or as alternative for MATLAB, because MATLAB took the trend to be quite expensive, and people envisioned having Octave. You can just run everything you can do on MATLAB, apart from having not the same quality of plots and figures as MATLAB, but at least it's acceptable. But then I don't think Octave could cope with MATLAB development, especially with the toolboxes And then presumably from that, people started to look for alternatives as well.
Yeah, I think that's exactly right. There is some advantage in having these paid computer algebra systems, and I think MATLAB and Mathematica and Maple put out stellar stuff. I think even though Sage Math is very powerful, and you have Magma and a bunch of these interesting non-commutative packages, they just don't compete with Mathematica. Mathematica has paid support, and they have some really, really fantastically good scientists keeping it up to date. So, I mean, open source is good, but I think the only way you can really compete with this is to have a huge, huge ecosystem, and this is maybe the single advantage that Python has over say Mathematica, Maple, Octave, MATLAB, right? It has just a bigger ecosystem, but with that leads to a bunch of inconsistencies. So not all the code is good all the time.
Right, because it's a power of community, but then it lacks the solid architectures. But then I was curious, when you implemented your Fourier transform and the Fourier expansion code, what did you use? MATLAB or Octave or?
That was an Octave. I didn't know how to program at all, and I just I like numerical linear algebra. I really like this, and so said, oh, matrix laboratory, everything's a matrix. Okay, I can do this. Like everything is a vector or a matrix. And I just started, from the very beginning, I started learning how to do vectorizations, and that made for me, that translated a little bit easier, right? I mean, there's this funny thing I say, I speak some languages as a hobby and I study them, but I always start with the grammar, and people say, well, that's weird. Why don't you start with the vocabulary? So, well, the vocabulary is just some random sequence of letters that mean some words, but the grammar is like the algebra, right? You have these parts of speech and they go together in a certain way, and those are sort of like functions. And then people are like, okay, that's weird. You're weird. I said, thank you very much. I appreciate it. But
so you look at it from a mathematical point of view, finding the hidden model that drives all of that, and this random sequence will make sense when I understand this hidden model. That's really pretty interesting look from you to see to envision things that way.
Yeah, and so the same in computing. I started with linear algebra because to me that's the most well-developed sort of field of mathematics, applied and pure, right? Linear algebra just has so many volumes of work. There's a computer language that does that. Okay, this is where I need to start. And that's how it all started. I said, okay, I can do this with matrices, but it'll be difficult for me to do this with starting from, say, Java.
Yeah, that's also pretty interesting because now you mentioned the Python, that Python had the leverage over the others, the paid software, or the software that has a paid license. They have a strong ecosystem because they hire highly skilled engineers and scientists to maintain the package like Mathematica or MATLAB. But then Python had more advantages than those because it leverages the power of community. A lot of people are using Python. However, we got this kind of the side effects of open source, that architecture is not solid enough, or there is lack of architects for that. So when did you decide to switch to Python, and when did you give up about Python and decided to move completely to Julia?
Well, that's sort of funny. My friend who brought me into data science originally said, okay, Clark, look, you're using Octave. No one else is using Octave. Everyone's using Python. It separates you. You know that. I know that. You got to learn Python. And so I just started learning Python. But I heard for a long time, like once you start using Python, you won't go back. And I just didn't have that experience with it. I was like, Python does things strangely. I still tell people, what's this deal with like half open intervals? Coming from the world of non-commutative geometry, when you have like a closed on one side and open on the other side, like, well, that's not a compactifiable topology. Why would you do that? And people are like, why do you care about what topology Python uses? Because I'm a data mathematician. I need to know the topology. Right? Which, that definitely put me at odds with people. But that, and then having a row major language is a little bit frustrating. Also, there's some small debate about zero indexing and one indexing. And I know a lot of programmers prefer zero indexing, and I get that. I'm dealing with, discrete systems. I feel like discrete systems ought to start with a sub 1, and continuous time systems should start with time 0, like time elapsed, right? So you have an initial standpoint. Indeed. But so, from the point of view of matrices, I started with matrices, and the upper left corner is A11, not A00.
Right. That makes sense from topological point of view of it. Right.
Exactly. So I prefer the one index language, although it's not a big deal. I can, I from time to time play with Scala, and that's zero index, and that's fine, and I can get along with it. But I'm usually not doing numerical computations there.
Yeah, so I
So
remember
trying
your
to do numerics, I
LinkedIn.
like this one indexing.
Yeah, that's really great because I have seen your LinkedIn post one time, and it triggers a lot of discussions regarding the indexing, whether it starts from 0 or 1, and it was pretty fascinating to see how people react on that, or that kind of simple thing might confuse how to deal with data.
Right. And so, I understand where people come from on both sides of the issue, but having used, now I've programmed through Octave and Python, and I played with R for a little while, which is pretty cool. And now Julia, and I'm looking, every once in a while I like sort of delve into Scala, which I think is a cool language, and also Rust is a little bit. Rust and F# are sort of my next languages after I need more things that are not just numerical. I sort of like the functional way of doing things, so I like Scala, F#. But when I started doing this, I said, look, you need to use the right tool for the right job. Right? Octave is not good for everything. It's not good for say writing web apps. It's just not good for that at all. It's good for doing numerical computations. Python, I know it's sort of like the reigning king, but I just don't like the way that it functions and it works, and it's slow, and it's, being in a renewable energy company, like sort of looking at it, the carbon emissions of its like automation, like, okay, I just need to do something else. I just need to do something else. So, I think Julia for me fits the most number of things that I need to do the things that I work on.
So you think Python, because they try to make it more generic and fits for a lot of purposes, it lost, or like we lose this kind of purposed language, where if we use it for numerical computing, it's become slower because of all of this hierarchy of layers that are optimized for the generic way of doing applications and so on. And then now you focus more on things that you think it's fits for doing computations and the numerical simulations, which now this is why you moved to Julia.
Exactly right. I mean, there are a couple problems I have with Python. NumPy is, for all intents and purposes, its own separate language. Right? I'll give you some examples of things that like drove me nuts, and I couldn't like wait to get away from Python. The half open intervals is something that no one cares about except me, but I that really drives me nuts. It's like, wait, why? If I go from 0 to 5, why does it not give me 5? I want 5. I want to end this in. So like the next thing should be 6, not 5. That drove me nuts. The row major thing is troublesome because, in mathematical physics, a row vector is a pseudo vector, right? So the transformations in doing mathematical physics they're not vectors, they're pseudo vectors.
Rows.
And say, like,
right.
Your primary thing is not the thing you say it is. This is wrong. I object. I don't like this.
Yeah, I mean, this is how it's now trying people to try to call it from Python, but as the rigorous definition, as you said, it's like a pseudo vector because it's now transposed. But yeah, that's a way. Most of people try to get away by calling it a row, but it's not really a row.
No, I got it right. So I had to learn all these other tricks just to do the things that I already knew how to do, and like you can make a column vector, but it's a vector of rows. Like,
indeed,
right? Okay, I got it.
Those kind of
the
tricks,
thing that like really made me go, I can't take this anymore, was I didn't realize that you had to specify things by an array in a data frame, and so it is okay. Let me give a matrix, and I want first column and third column. And I guess I should put them together with an HCAT. And it gave me a long row. And I said, what are you doing? I want 2 columns. And it gave me a super long row. And I was like, I can't do this anymore. This is just all wrong. They're not doing things mathematically. They're doing things computationally. So at that point, I just stopped. Stopped using Python.
Yeah, I can understand the frustration, because the main essence or motivation that those script languages should reflect or mirror what we see on a textbook, or like doing computations by hand, but at the end they deviate mostly from that, and then you start like they are dealing with numerics in memory basically without having visual understanding of what is happening. So what you are working now on at the moment? What kind of projects you are working now?
Okay, well, as I said, I started actually a pair of companies. They're kind of two branches of the same thing. One's non-for-profit to do R&D, and one is the commercialization for profit.
Wow, that's really nice.
Yeah, the major company is called Enerjuice, which is energy and juice put together. And so we're sort of a renewable energy optimization, financial tech, IT thing. So we have a couple of projects. The biggest one that we're really trying to work on is load balancing, energy capture, redistribution, and we're sort of trying to optimize how we sell the energy back to the users of it. So, for example,
so why it's called energy juice? Just if you...
we're trying to squeeze power from motion. So, for example, right, we're looking at kinetic energy as one of our major and maybe the major energy source. I'll give you a couple examples. If you look at Chicago O'Hare Airport, I'm in Chicago. There's roughly 15,000 cars that come through the arrival and departure gate a day. There's a company called Motion Power that makes these basically energy collecting speed bumps, and they put them in Sainsbury's in the United Kingdom, and they're collecting enough energy off the cars in the parking lot to basically run the lights and the cash registers. It runs the tills. So okay, that's a cool idea.
Yeah, indeed.
But these cars are going slow, and so I did some calculations. How fast are they going? What's their average speed? They're coming through Chicago. In our airport and in several other airports, they grate the road. So when you drive over it, you get this, and so you're just dispensing that energy as heat and brake pads.
Right.
Instead of slowing the cars down that way, why don't you slow them down with very small speed bumps that are collecting energy? And so I did some calculations, and I have a map for where I think speed bumps should be placed. It's a very specific, optimized. I had to run a lot of numerical simulations, but there's a very specific layout and a very specific number of these things where I think I can actually power the entire airport transit system with just the cars coming through the arrivals gate.
Oh, that's
right. And we have some specific numbers.
Really great, yeah.
We have some specific numbers of how much that would save Chicago's O'Hare Airport, and it's in the millions of dollars, US dollars yearly. I'm not going to tell you all the details because I actually want to get this piece commercialized, but that's one thing. So we're trying to just collect the kinetic energy from the cars coming through the airport and sell it back to the airport.
Yeah, that's really great, and that's also very sustainable. I think having energy that way would reduce the using of fuel, fossil fuel, and all of that. That's smart, and you are using Julia for this at the moment. So
yeah. Right now we're pure Julia. There is some debate as to whether we are going to continue as a pure Julia shop. My other co-founder is a Microsoft whiz, so he may want to perform in C# or F#, and that's fine. I mean, we can work, but all the numerical and optimization work will be done in Julia.
But why the other co-founders envision C#? What they envision as a difference from Julia, or the advantage of using F# or C# in that?
So
apart from Julia,
from his perspective, he's a software engineer, not a mathematician, and so software engineering in C# is done. It's something he has done, and it's a lot easier for him to sort of translate into how to do the deployment. Although I suspect we will end up being a pure Julia shop in the long run.
Right, I see. And when did you decide to move purely to Julia and leave Python for numerical computation, numerical simulations?
So
when
I
was
had an
the
intern,
moment?
Yeah, a couple summers ago. So I work for a logistics company as well, and I price truckloads through the United States. And I had hired an intern who I believe now works for Tesla, but she was doing a master's in artificial intelligence at Northwestern. I said, okay, this woman is very intelligent and like really knows how to do things. So I brought her on to work under me, finishing her master's degree as her like work study program. So great. She was working pure in Python, and there was something. I rebooted the computer and updated to like Ubuntu 22, and there was some funny communication between Spider, which is the scientific Python development environment. Right? So Spider is what I was using. Spider wouldn't load, and Python 3.10 wasn't loading with it, and Ubuntu said you don't have Spider. And so it took me 2 days to like just try to even get Python to work again, because I'm not a software engineer, I'm a mathematician. So I said, let me just let me just run it in Julia. I've kind of been playing with it, and Julia did it, and I set up a neural network. She set up a neural network, and her neural network ran. It was great, and mine went.
See.
And I was like, oh. I mean, I knew Julia was fast, but that was really fast. And so I said, okay, well, let me go back to something that everyone understands. Let's go to XGBoost. Right? It's just a wrapper in Julia. And so one thing I like to do is I like to write genetic algorithms to fit parameters. Okay, what I'm going to do is I'm going to write a genetic algorithm, and I'm going to have Julia try to find for me the best set of parameters for XGBoost to price out this particular lane. I think it's Chicago to Dallas we were looking at. And I used to do this in Python. And I'm telling you, literally, I would set it up in Python. I would run it. I have a big, powerful computer here. It's like 64 gigs of RAM. I ran it in Python, not in GPU, just in CPU. I would set it. I would go to lunch. I would come back, and my program would be done. So when I started using Julia, I said, oh, let me just translate this. This is a good learning exercise. I did the genetic algorithm. I wrote the same thing, and I said enter, and it says, okay, done. I said, wait a minute. It didn't run. I must have made some mistake. So I said, okay, just print a dot for every generation that you run. He goes,
right.
Like,
yeah, that's
it ran this.
Power of Julia.
And so I checked the initial parameters, and I checked the optimized parameters, and they were very different. I said, I don't know what it did, but it did it fast. Really fast. So I said, okay, let me make this like a really, 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 really big program. Make the initial population huge, and run it for like 1,000 generations, and it goes. I think it took it like 18 seconds, and I said, "Oh well, I just lost my lunch break." So,
I can imagine.
That was it. At that point, I was like, "Okay, I've been like, there's no point in me like trying to get Python to work again. I figured out how to do the thing that I really need to do in Julia, and it was easier and it's way faster." So, and then of course there are things like it doesn't have a non-Archimedean topology, and vectors are vectors. And when I ask for 2 columns, it gives me 2 columns. But when I ask for 2 rows, it gives me 2 rows. So it basically ported over MATLAB's matrix calculations, right? The numerics in Julia are equivalent almost to MATLAB's numerics, and so it just works better for me.
Yeah, that's really a beauty about Julia. We had several use cases where we are using now Julia purely. In particular for our startup Molkit, and also my co-founder noticed the same, and that it has a comparable speed to Fortran. But I think the way that they designed it to having this pre-compiled functions in the memory leverage this way of having a hybrid system between Fortran and the MATLAB at the same time. So, and it's open source. So that's really great. And then what do you think still Julia lacks at the moment? So what you dream, like if we have it in Julia, that will make it greater, and you will make it love it more?
Yeah, so I think what's happening, we're starting to see some more adoption in it, right? While I don't necessarily want to condone BlackRock, I think BlackRock has switched onto using Julia because they recognize the advantages. Like when you're a hedge fund and you need speed, what have they been doing for so many years? They've been scripting in Python and then actually programming it in C++, right? And I think there are several hedge funds around Chicago that are realizing, oh, we could just do the whole thing in Julia from the start. We don't lose any speed in the development, and we don't have to translate the code. Right, so you can develop almost as quickly as you can in Python, but you can translate it into, well, you don't have to translate it, right? So you don't have to write the code twice. And so I think that there are a couple of hedge funds, 2 at least that I know of in Chicago, that have sort of started using Julia. So there's a momentum going. What would make Julia better is it has to have a better ecosystem, right? The thing that's very frustrating for me using Julia as opposed to, say, Scala or to Python is that when I look for something, there's like sort of an older deprecated package, and
indeed,
right, not all the packages are updated. So Flux changed a lot. So I was using Flux in Julia 1.4, and then I tried to use it in Julia 1.10, and the commands had changed on me, right? So that was a little bit frustrating. And say, oh, you have Lux now too. Oh, and you can just like write it by hand. Okay. So the ecosystem, as it grows, we need a bit more consistency. This is one thing I think Python does particularly well, is it has an ecosystem, and they have a lot better checks on the bigger packages.
So I see. So do you envision by having hedge funds interested in Julia that would push forward and make like strengthen the ecosystem and make it bigger and also more powerful?
That will be part of it, and then I think Now, I've said this many times. I just enjoy doing what people would call data science. I call data math. I enjoy doing this more in Julia. And a few years ago, this is another fun project I worked on. I follow Formula One racing and I follow Formula E racing. A few years ago, there was a series called the W Series, and this was an all-women's driving series, is equivalent to Formula 4. It was a support series for Formula One, and one of the teams was called Court DAO, DAO, and so they were all crypto funded. And so we actually made some NFTs for them. I formed a team called Team Quantum Punks, and the NFTs were actually quantum walks on graphs, where we like took the pictures and we like sort of made the helmets like turn and do some like crazy wave interferences. This is all just like a quantum walk on a torus, which I programmed in Julia, and it took just a few seconds to actually render the whole picture back, which is cool.
Oh, wow.
I had tried a similar thing in Python, and it took 1 minute per frame. So I was only able to do 300 frames, and it took me like a long time to get it done. And Julia, I was like just producing these, same techniques, and they're just like, oh, here's your new NFT, here's your new NFT, here's your new NFT.
Yeah.
So I started playing like quantum random walks on graphs in Julia, and it was just going faster. And another thing, I was looking for like maximal spectral expander graphs, and I had written this like chained optimization program in Python. I put a paper out about it, one of my favorites. And then I just tried a simple Monte Carlo in Julia, and it got like an even deeper result, and it took it 25 seconds. The Python one I ran for an hour, and I was like, oh man, I got like almost the optimal expander in the whole universe, and Julia found one slightly better, and it took it 25 seconds. I said, what have I been doing with my life?
Oh, wow, remarkable. Yeah, that's you can save a lot of hours with using Julia.
Yeah, and a lot of compute time and a lot of agony. I have yet to sort of re-implement the algorithm, the original algorithm back into Julia. I just didn't find it necessary. I just have enough firepower to do simple Monte Carlo.
Yeah, that's really great to hear about that. But then now, as any programming language, some scholars and also some software engineers who are a bit older now and have used several languages in the past, most of them are dead now or buried like in the wood, because it's now the world is moving with new languages. Pascal, for example, is ended. We had Python to shine and to spark out from the 90s, and now we have Julia. So what could be the killer feature that would kill Julia at all, and then another language will emerge? So what do you envision about like the death of this language, how it could be? Or
there's a couple of things that I see happening. So Mojo is an interesting, right? So this is for all the Pythonistas who they love Python and they won't give it up because they figured out actually how to program. Mojo is like, well, I think people are realizing the problems with its memory allocation and its speed and its energy consumption, right? There's a bunch of things we need to think about now in computational resources, right? It's not just speed. It's not just memory allocation. It's also energy consumption.
All right.
This is a real deal. So I'll give you an example. I interviewed with and was ultimately offered a position at Oak Ridge National Lab to enter their quantum machine learning group.
Yeah.
And one of my principal tasks was going to be translating some of their old code into new Julia packages developed at Oak Ridge. That was going to be part of the job. And I think Oak Ridge at the time was still setting up their supercomputer, which I've looked up the stats on, is currently the fastest and most energy efficient per computation that has ever been built by quite some way, actually. I mean, they're measuring it logarithmically. It's that good.
Oh, wow.
And they're trying to get onto Julia. Right, so there's some like real momentum here for some big players. Right? Oak Ridge is not a tiny player in any particular scientific discipline. They're not a tiny player. So problems I see for Julia going forward, like there are other languages that are going to be better for other things like Rust. Rust I see is like really kind of taking over a lot of the ecosystem now. If Rust's numerical capabilities and machine learning and data science capabilities get good, it could give Julia a run for its money, because Rust is somehow even faster than Julia. It has better memory allocation, better garbage collection. It has a lot of features that like you really want out of a programming language. Julia has like the numerical everything, and Rust has kind of everything else.
Yeah, like sort of what surrounds the numerical computing.
Yeah,
like the base
exactly.
of it. Yeah.
Exactly. So you're starting to see now the Rust plugins for Python, right? Because people are realizing, oh, we need not Python, we need Python-like stuff, and I think that's kind of the point of Mojo. So I could see Mojo, if it actually takes off, and Rust, if it really improves its numerical capabilities, keeping Julia as a somewhat niche language, I could see that happening.
I see. So that's bizarre. So that means that will be like the nail in the coffin of Julia, because people will be interested more in Mojo and Rust and use it quite more, and then the ecosystem collapses of Julia with time.
Possibly.
Like potentially, yes.
I think there is a way for these to sort of like coexist. You know, I mean, like R is going to continue on for a long time, and so R's been sort of usurped in every possible capability. In particular, say like tidyverse in R is now tidier.jl. So Julia has like ported over all of R's statistical capabilities. I think we should point out something, right? At JuliaCon a couple of years ago, one of the keynote speakers was the chief clinical scientist from Moderna. And so I think a lot of people should realize that one of the major COVID vaccines was developed in Julia.
No, I see. That's bizarre.
Right? I mean, I think that was a big push, right?
Yeah. Because now it leverages the power of users, like having a strong ecosystem of development, but now having several users and a lot of users also pushes or requires a demand for developing the language and to keep it going.
Exactly. So I see Julia growing maybe up to a point. There is, for me, the killer application would be if someone can actually build a quantum computer.
Yeah, that's a dream.
I'm very skeptical about it. I soured on quantum computing heavily in 2023. But there are methods by which, you know, certain quantum computing like algorithms will actually be useful. Yeah. And you know, I interviewed also with Pascal, which was at that time Q & Co in the Netherlands, right? So Benno and Vince, and they were a Julia shop. Yeah. Right. And that was kind of the point. The reason they interviewed me was like, oh, you're a Julia guy. Let's do this thing. And they, even at that point, they were saying, what is the point of getting this super fast quantum computer and then running your stuff in Python? You just give all your advantage back. Yeah. It doesn't make any sense. Like all the advantage you get with a quantum computer, you have to give back in Python overhead. That makes literally no sense whatsoever. Yeah. Why not just run Julia in the first place? Yeah, right. That's a remarkable and very visible in a lot of platforms at the moment. You lose or you give back the all computational power or most of it because of these layers of complexity in Python, and then the speed is gone basically. And I think it's also important to know, one of my friends here in Chicago is maybe one of the principal Julia developers for OpenAI, and so I think a lot of people don't realize how much of ChatGPT was actually coded originally in Julia, because its numerical processing capabilities can actually churn through the data. Yeah. If it were purely in R and Python, then we wouldn't have ChatGPT yet. We just wouldn't have it yet. It would take too much time and too much. We don't have enough electrical resources. Yeah. Right. Yeah, I go back to this electricity consumption thing, right? That's my idea now, but Oak Ridge told me at the time they didn't build the computer twice as fast because they couldn't afford the electricity bill. I mean, let's put it this way: that's part of the equation, indeed. Yeah, it is now in modern high-performance computing. It is. It's as big a resource consideration as time and memory consumption. Yeah, I remember the story when I was in the second year of the PhD. One of the machine has to be shut down because they noticed that the users are not using it quite often during the week, and they calculated the energy bill, and they found that it needs this amount of cooling, and then so on. Then the IT decided to shut it off, but we missed it a lot because we had things that are stored on the scratch disk. But then we were thinking but that's a nice hard disk to have and to access via the internet via SSH, for example. But then if you think from electricity wise, that's a huge bill that has to be paid, and so that's an interesting perspective that's now demanding, especially with high siege and high prices in energy and so on. That's practically I would think very important to look at. So and not to lose everything and to pay more in electric power. Right, and that is, that's part of the reason that I having traded electricity and have been interested in renewables for a long time. That's kind of how Enerjuice even got its start, and that's part of the reason that we've decided that Julia is going to be our way forward. I mean, it has all the resource allocation solved that we need it. to solve.
Yeah, that's really great, Clark. So I hope for your company, Energy Juice, and I wish like you as a co-founder and your co-founders as well, really a great success in that, because that's also will demonstrate how computing can make the world more sustainable and having less consumption of energy and so on. And this is reflects also on the quality of life, because people will pay less, and then there will be more room for innovation and so on. So really good luck with that. I think I've learned a lot during our discussion. That was very informative discussion. Do you have anything you wanted to tell as advice for young computational engineers from your experience so far?
Yeah, I mean, I think it's very important to keep in mind that I think a lot of people look at me as a Julia evangelist, but if you speak to me in person, I'll say you have to use the right
Yes.
tool for the right job.
Yeah.
Right? If you're just writing a little script and you just need something done quickly, why not use Python? I mean, it's just a little script. If you're trying to automate something major, you have to take into account more of the resource allocation, right? It's not as simple as equation as, well, if they're doing the right thing with it, doesn't it count? So, well, if they're doing the right thing, then maybe they knew to not use Python in the first place, right? If you're doing some statistical analysis, R is a great place to be. If you just need numerics and nothing else, Octave and MATLAB still take care of it, right? So use the tool that gets the job done for you the best. For me, data science, data mathematics, quantum computing, optimization, I have found Julia works the best for all of those things for my purposes. And so that's why I stick with it. But for the young people coming through, use the right tool for the right job. That's it. You don't drive in a screw with a hammer. You use a screwdriver.
Yeah. Yeah, that's
right. So
that's a very golden advice. Yeah, for all of young developers, because that's what they need. They stick. We need to use Python, and they try to enforce the tool, not to look for the right tool for the job they have.
Yeah, and one final thing, like Julia Plots looks really, 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 really nice. I think that was one of the best packages they've ever developed. So the plotting in Julia is just like, it looks professional, and when I sort of think back about how Python did it, Python looks a little bit sophomoric, Matplotlib versus Julia Plots. That's to my eyes. I'm not an artist, but a lot easier to read and display to my company what I've done in Julia Plots. So that's like a really pristinely good package.
Yeah, that's a really very nice one, and a high quality package comparable to MATLAB, even in the kind of resolution and the quality of colors and so on. So yeah, thanks very much, Clark, for being here today. I think that's a very informative session, and we will see one another in the future sessions indeed. A lot of things to talk about regarding the success of your company, but also the use cases that you are involved in. That will be interesting for sure. So thanks again, and I wish you a nice day.
Thank you, Taha. Shukran kathir. Dankjewel. Thanks a lot. Merci beaucoup. We'll talk soon, I hope.
Yeah, we'll talk soon. Yeah, thanks very much.
All right. Bye-bye.
Bye-bye.